It's like the universe is trying to say something, because I did not coordinate with Steve the title of the talk. My talk yesterday was full stack reactivity. Today it's full stack Plone deployments. There's full stack in both talks, and we did not agree on that in advance. So Steve McMahon was supposed to give this talk today, but he had a personal emergency, and unfortunately, he could not come to the conference. You probably have met him if you've been around Plone for a while. This was a picture taken at the Emerald Sprint in 2014. So I'm here in his place. My name is Fulvio Casali. And I'm going to talk about full stack deployment with Ansible. How many here have used Ansible, whether with a Plone playbook or on some non-Plone projects? Show of hands. Okay. About half. So, what do you mean by full stack? In today's talk, full stack means basically the entire stack on the server side. We're not including the clients today, but everything that we need to run a Plone site adequate for production purposes. We also want to support server requirements like monitoring, log analysis, mail transfer agent. So there are different approaches to doing this kind of thing. Two major paradigms, if you will. One is using containers. An example of containers, or two examples of containers, are Docker and Juju. In the container paradigm, the working units are the individual applications that make up the stack. So the green, yellow, and red blocks above the Docker engine are the working units that you want to control. The other paradigm is the orchestration paradigm. And in this paradigm, you have a state specification, an orchestration engine that drives the orchestration engine, and with that specification and one orchestration engine, you can repeat multiple deployments to as many identical servers as you want, and in this case, the working unit is the entire server. The entire server, and so which one is better? The answer really depends on your priorities. Do you want to deploy an application unit multiple times, maybe on the same server, or do you want to deploy the full server all at once? In the cloud world, where servers, instances running on the cloud are basically, you can think of them as disposable. Just setting up the entire instance at once in one full swoop is the right choice for Steve and for me as well. Your choices may differ. So what tools do we have? There in the provisioning space, in the server provisioning space that's open source, 4 tools dominate the scene. Chef is built using Ruby and Erlang, for real. And for configuration, it uses the Ruby language. Puppet is also built on Ruby and uses Ruby again for its configuration language. Whereas SaltStack and Ansible are built in Python and use YAML for configuration. We just choose Ansible. SaltStack uses a client-server model where basically you have to install components of SaltStack to use it, both on the client and on the server. Whereas Ansible is agentless. There is nothing on the server that knows about Ansible at all. It's all running on the client. It's a bit simpler, and simplicity wins for our purposes. So a quick introduction to Ansible. And before, for those of you who have never seen Ansible, I just want to deviate a little bit from the slides and show you the way that I have explained it to a fairly non-technical person. So you might have seen one-click installers that many hosting providers have these. So you go to your hosting provider control panel and choose, for example, you want to install WordPress. You want to have a WordPress site. And in their control panel, they have just a very simple UI where all you do is you choose which domain you want to deploy it to, and another option, and you push the button, and it does everything for you. Ansible is is the same idea except without the UI. So in Ansible, you use the command line, but it is just one command. After you have everything you need on your local machine, it's one command or one button in the one-click installer model of hosting providers. So actually somebody could build a UI on top of this. I'm sure somebody has done it already. So I just set up a droplet, like a very cheap instance on DigitalOcean, and ran Ansible just an hour ago and set up a Plone site that way. So let's get back to the slides. All right. So the building blocks of Ansible. Oh, and by the way, Ansible the name Ansible comes from a science fiction novel called The Dispossessed, written by Ursula Le Guin. And in this novel, there is a physicist, Shevek, who invents a device for instantaneous communication at a distance, and it's called Ansible in the book. Unfortunately, the Ansible Corporation that built our Ansible used sports metaphors for all its terminology. So the pieces that we work with in Ansible are plays, which are individual state specifications, which are ideally idempotent, so you can run them over and over again. Playbooks, which are just lists of plays. And roles, which are reusable lists of plays, so you can install them in for your specific case, and reuse them in your playbook. As I mentioned before, the configuration language is YAML, which is, YAML stands for YAML Ain't Markup Language, so it's a backronym, I think it's called. And it's used for all of Ansible's configuration files. It expresses Python data structures in a text outline format. So just have dash and then list items. If a list item contains a nested list, then you have a dash followed by key value pairs with the second and following value pairs indented, just like Python. The basic units are strings, numbers, dictionaries, and lists. Here's an example. This is a fragment of a playbook. So here we see a list of 2 items. Each of the items is a dictionary, so it has a key value. Each list has multiple key value pairs. And in this case, this example comes from Ubuntu's apt package manager. So obviously, you can see that the first line is just basically documentation, or it's something that you will see in the output when the command runs. It describes what it's doing. The actual command comes in the following line, and the command is apt, and everything after apt is just parameters passed to the apt command. In the second case, we are actually iterating. So the variable additional packages contains a list, and the with items specification allows us to basically iterate over all the elements of that list, where each item is the iteration variable. So this will repeat over all the additional packages that we want and passes them to apt. Ansible playbooks have templates. So here you see the template syntax. This comes from, obviously, as you can guess, this comes from the buildout.cfg template in the Plone Ansible kit. And template files can be copied to the server to be executed there. So here we have basically an if block, and inside the if block, a for loop. And this basically just adds additional eggs to the list of eggs. Plone and pillow will always be there. So roles are reusable playbooks. So you can use roles inside of your playbooks. You can either write them yourself or check them out via Ansible Galaxy. And here's another deja vu, because in my talk yesterday there was also a Galaxy, different Galaxy. All right. Oh, and this is how you use roles. So this would actually be the top level playbook, the one, actually, an example. Here the playbook.yml is the top level playbook, and it actually looks very similar to this. This is just a fragment of it, of course, but so it just lists all the roles that we want to use. And each role, again, is a playbook. So there's nesting that way. And these are pieces of a Plone server that we want to install. So you see, we want to install Varnish, HA proxy, and Plone itself. All right. So that was Ansible in general, and now that we're going into the Plone Ansible toolkit, which what we have available are a role and a Plone playbook. Let's start with a Plone server role. So the Plone server role only installs Zope and Plone, nothing else. It installs it in a Zio configuration. It includes supervisor to manage processes, and it adds backup and packing cron jobs. And this one, the Plone playbook actually downloads from Ansible Galaxy. So that's Ansible's PyPy. The Plone playbook is the one that includes the previous one, the Plone server role, but it also adds everything else we need on a server. It adds HA proxy, it adds Varnish, it adds Nginx, it adds, it configures postfix, and other admin stuff. This one is available from GitHub. So you can choose whether you want to start with the Plone server role or with the Plone playbook. If you want to build your server your own way, the Plone server role might be more interesting for you. So you write your own playbook and use the Plone server role. So this one takes care of just Plone, and everything else you build yourself in your playbook. But if you want to basically follow the practices that are kind of actually step back. The Plone server role is very similar to what you get if you run the unified installer manually, except it's done remotely from a client. It just runs it on a server. With the unified installer, you actually have to be on the server to run it. The installer team chose, all these other components, Varnish, HA proxy, Nginx, and all the settings, the configuration that makes the most sense, and condensed that into the Plone playbook. The server role, you can either use, you can use the canned build-out, which is, like I said before, it's very similar to the unified installer, or you can actually use your own build-out. So if you use the canned build-out, you can specify how many Zio clients you want. You can specify the memory profile and specify any additional eggs and version pinning and so on. The playbook, the full stack thing, gives you everything else. One payoff of using the playbook is that you get, for example, you get a client restart script. So there is a client, there's the script that can only be built by the playbook because the playbook knows how all the other pieces are installed and configured. So So we can use that knowledge to integrate all of them together, for example, with this script. And so it restarts all the Zio clients, putting a wait between each of them. Before restarting them, before restarting each client, it removes it from HA proxy. Then after it restarts, after it's done restarting, it fetches the home page of each virtual host to warm up the cache, and then it adds it back to HA proxy after the page fetch. And it also flushes the varnish cache. So this is all done with one shell command. Major options of the playbook. So you can skip the install of, one thing I didn't mention is actually Munin, so you can actually integrate monitoring, configuration of monitoring for your server. But you can skip any of these pieces individually with the playbook. You can also set up SSL, passing it key pairs, and those will be installed for you. You can tune the cache the way you want it. It also sets up a message of the day for you, so when you actually SSH into the server, it gives you like a summary of all the ports that are in use on that server and other stuff. It sets up a postfix relay. Okay. So that was what we have currently for Ansible. Now, how can we actually configure these things? So the playbooks, as you've seen at the beginning, contain variable declarations, and all of the options basically are configured just with simple variable declarations. So you can list, I think there's an example, you can list all the eggs that you want, any additional eggs that you want on your server. You can pin your versions. You can, change your ports. You can set your admin email address, the initial Plone admin password, whether you want to use Munin or not, and loads of options. However, the trick is, how do we do this in a maintainable way? So the easiest strategy is by using a local customization file. In fact, this is actually required. You need to have a local configured.yml file to run the playbook. It expects it, and it doesn't so much expect the file, but it expects certain variables to be declared, like the admin password. It will not run if you don't specify an admin password, and that you can only do in the local configure file, unless you start messing with the playbooks themselves, which is exactly what we're trying to avoid. Keep all of your configuration, all of your customizations in just one file. So you can override any setting. There are samples for several typical configurations. So for example, you can have a very small server for like a 0.5 gig cloud image. You can have a small server where you can run maybe two Zio instances, or 2 Zope instances. You can have a medium size that has more clients and more caching and larger caches and varnish and HA proxy. So and those are provided as different sample configuration files, so you can just copy the one you want to local configure and then edit it. The Plone, the Ansible playbook you download, you pull from GitHub. So, so it will be basically, you will have a local Git clone for that, but the pulls will never overwrite your local configure. So that's another reason to use that as opposed to going and changing the other playbooks, because those might get overwritten when you pull. So this is one of the samples. This is for a medium size. There are, some of the variables in the configuration file for a medium size server. Like I mentioned, you need to specify the admin email. You need to specify the initial password. The time zone is the one feature that I added to the Ansible playbook. You can decide, whether if you're going to use Munin, you can specify the IP address, and then here are actually the pieces that kind of distinguish this sample from the other samples. It gives you 2 clients, 15,000 objects for your GeoDB cache, and 750 megabytes for maximum memory. Another strategy is to fork it. So you can fork the playbook from GitHub, and then you own it. It's yours. You would use it if you don't like some of the major stack component choices. You can then, import it into your own Bitbucket account, for example, and go from there. One important thing is that the playbook comes with a Vagrant file, so you can test the whole thing locally on your local machine in a virtual box. So just by running Vagrant up in the Ansible playbook directory, you will spin off a Vagrant virtual box that uses Ansible as the provisioner to do everything that it would do on a server, so you can test it locally. And where we are today is we have pretty good documentation. It's in docs.plone.org. Every customization variable is documented. We support Ubuntu, Debian, and CentOS, but we would like more, of course, with your help. So join the team. The targets, the OS targets, should typically be the latest stable long-term support release of an OS or of a distribution, because cloud servers are disposable. So there really is no reason to target an old distribution. And that's it. Thank you. Questions?
Are you going to press return, or does that cost you money?
Pardon?
Are you going to press return, or does that cost you money on the...
Oh, I already did. I already did, in fact. But I can. It's just going to rerun the same thing again.
Cool.
but it's actually, I actually have it both in the Vagrant box, virtual box that I mentioned, and over here.
Yeah.
So this is what I just ran. So it's working for Plone 5.
Okay.
It was just released a couple of days ago. The version of the playbook and of the server role that supports Plone 5.
Okay. I did have actually on the Vagrant thing. Do the links work in the Vagrant when you run up a Vagrant instance, or?
Pardon?
Do the links work when you run up a Vagrant instance, or is there some trouble with the virtual hosting?
They work because Vagrant, it's running. The Vagrant sets up all of the port forwarding for you. Mm-hmm. So basically you have localhost 8080 pointing to the guest port 8080, mm-hmm. And so if you're loading localhost 8080 in your browser on the host, you're actually loading it from the guest.
Okay. I think my big question is, if you run it twice against one server, can you set up separate sites, separate instances on the same server, and do they share like the same Nginx postfix? Does that not work?
Yes, you can, but you need to be careful there. You need to basically. So you want to have, obviously you want to have different local configure files. So you run Ansible playbook. Actually, the way I have done it was by forking basically the main playbook. I had 2 copies of the playbook. One would load one local configure, and the other one would load another local configure that had several of the variables you need to change because the paths change, the ports, of course, need to change, but it is possible.
But do they share the same, some of the same resources that like Nginx and postfix?
Yeah.
Okay.
Again, Nginx, the Nginx role uses the host name that you put in your configuration file to name the Nginx config in /etc. Mm-hmm. So you probably want to be careful that it actually generates 2 different ones, but
okay, cool, thank you.
Have you had a look at something like CloudFormation? I've seen, I forget which company it was, but they did basically the same thing using chef recipes, and you can put it on CloudFormation, which does the same thing for Amazon, and you just put some XML in it, it does the whole lot for you. Have you seen how it compares? Or?
No, I've not.
But I guess the mystery is, does this actually create the servers for you?
No, you have to. You create the server yourself.
And you point it and deliver roles to particular servers?
Yes. So, you specify the IP address of your instance in the basic configuration file, and it will connect to that. And I don't know how. I use DigitalOcean a lot, and DigitalOcean allows you to reuse the same key pair. So then my Vagrant, all I have to do is specify the IP address because it uses the key that I already have on my local machine to connect to it over SSH. He can answer that question.
because for the IA team, we do that basically. We deploy also in Ansible the servers. So for Rackspace, Amazon, and DigitalOcean, we have playbooks which describe all the server and the data center and what kind of server, and deploy that first. So it's possible. It's Pyrex, it's also a Python library, and it's working really well, even also with OpenStack, if you have your own OpenStack setup.
Hooked it up to the things like Amazon have ways of hooking monitoring up to to create new servers and then to kick off some sort of process to configure it. Has anyone done auto scaling with Ansible? Similar to that?
I have not.
Auto scaling, as in under some sort of metric, it's under high load, create a new server, deploy the app, roll to it, and then
We do that with sensing.
with
We use sensing for monitoring,
yeah.
and then the sensor is basically telling Ansible to do that.
Okay, because it's push, it's sending the message out and going, and then what that goes and uses Amazon API or something else to create the server and then point it at it. Okay, sensor.
Can I ask you a question, please?
Sure.
What's the main advantage over a build-out configuration?
Well, for one thing, I mean, the first advantage is you run everything from your client, from your local machine. You just run a command and it does everything on its own, unassisted on the server. It also does, I don't know that it's possible to do all of the things that this does on the server with build-out. For example, well, first of all, you need to have Python, for example, to run build-out. And this one installs all the OS dependencies that you want for you.
Including Python.
Pardon?
Including Python?
Including Python, if it's not already there. That depends on the the OS targets that we support, of course. But all the package updates.
Python 2 is at least one requirement on this server. I think Python 2.7 something is a requirement for Ansible, because Ansible copies some Python code and executes it. So
That's right.
At least that, but you have that almost. So, but
Well,
everything else,
no, you don't. Like I actually tried it on Ubuntu 15 something, and it came with Python 3. And Ansible at that time, I don't know if it's changed, but at that time Ansible did not run under Python 3. So that was something that I had to hack the roles, the server roles, to actually install Python 2 before it did anything else.
Yeah. But everything else, yes, we install it via apps or something.
Right.
That you don't want with build-out.
Right. And by the way, it finished. Of course, the build-out already existed. The OS was already installed. Otherwise, it would have probably wouldn't have been finished by now, but it finished. And I just wanted to show you the MOTD. So that's the MOTD that Ansible sets up for you. Any more questions?
As a side note, you can have the same notification in some configuration files. Yeah, especially this is for setting up the server. But if you also want to maybe set up and check for the Nagios server or something, then you just go to another server and just manipulate or manage one file or so. So not the whole server is under control of Vagrant, Ansible, but the file which is rendered by Ansible then shows up. Be careful, this file is auto-generated, so this is just one macro or something you can put in the configuration files you try to manage. So you can integrate it in your existing setup really easy. It's not like all or nothing.
Yeah, and Ansible, if you Google it, Ansible comes with tons of roles that you can set up pretty much anything on a server remotely. Yeah, it's very easy.
And what's the best way to manage upgrades on the OS level on some of these machines? For example, in CentOS it's not possible to upgrade in place as opposed to Debian. So how would you
Replace what?
to upgrade in place?
Oh.
You need to rebuild the whole machine.
I would say the easiest way would be to spin up a new instance that uses the new OS version and run Ansible on that, and then copy over the data.fs and whatever you need from your Plone site, and shut the other one down, and of course fix the IP addresses, kind of stuff. All right, if there are any more questions, you can talk to me outside. Thanks.